Hi, in this video I'm going to tell you a little bit about work and give you some examples. So what the heck is mechanical work when it comes to physics? Well, on the back of your reference tables you'll find an equation that says work is equal to force times distance. I've put little arrows over the force and the distance because, and it's actually displacement, sorry. I put little arrows over it because these are vectors. So, when we multiply them together, it actually makes work, which is a scalar quantity, and it's even though that it's a product of two vectors. All right, and it can be negative or positive depending on what direction the force vectors are pointing. That doesn't mean that it has a direction. It just means that you can have negative work done on something, and you'll get a little used to that as we go along. So let's look at an example. So how much work is done by a force if you have a 3 Newton force on a box and the box moves 50 newtons in the same, or 50 meters, in the same direction as the force? Notice that they're pointing in the same direction. We have work times force, that's our equation. And because they're pointing in the same direction, we can just simply multiply their magnitudes together to get 150 Newton meters of force, of work. Now, a Newton meter is also known as a joule. So we could say 150 joules of work, and that's the more typical unit to be used. We'll also realize this is units of energy as well. So let's take a look at another example. So example 2, let's say that a 3 Newton force is pulling upward on a box, but the box moves in a horizontal direction to the right. How much work is done by this force? Well, in this case, because the forces are perpendicular to each other and no part of the force is pointing along the direction that the box is traveling, there's actually 0 joules of work done. I know that sounds a little weird, but that force is not doing any work on the box. There may be other forces that we don't see that are doing work on the box, but in this case, this force is not doing any work on the box. Let's look at another example. Let's say that the force, a force is pulling on the box in the opposite direction that the box moves. And this is possible. This will result in a negative work because the vectors are pointing in opposite directions. You can see the force vector is pointing to the left and the displacement vector is pointing to the right. A fourth example, let's say that part of the force vector is pointing in the direction of the motion. So really what we want is the x component, fx, and we know that fx, from the back of the reference tables, you can find it. Fx is calculated by using the magnitude of the vector and multiplied by the cosine of the angle. So this is fx, and we know that that component of the force is pointing in the same direction as the direction of motion, and so that's the only part of the force that we use. Multiply that together and we get 130 Newton meters, or 130 joules. Example 5, let's say we have a force that's pushing against a wall that doesn't move. How much work is done by this force? Well, because there is no displacement, there's 0 work done. If you push on a wall with 25 newtons, you are not doing any work on that wall. You might be doing work on your muscles because your muscle fibers are moving back and forth to produce the force, but you're not doing any work on the wall. All right, so how much work is done by lifting a box onto a table? It's kind of useful to write a 3D or 2D image of this. We can see that the box is going to go up. That means it's going to move through a distance, and we know we're going to have to use a force to pull that box upward. How much force will we need to pull that box upward? Well, we'll have to use the same amount of force as its weight. Its weight force pulls downward, so in order to move it upward at a constant speed, or to move it upward at all, we're going to have to pull it up with the same amount of force. Of course, I've got my 3D image as well, but it's easier to see this with a 2D image. So the force times the distance. The force is going to be our weight, which is just mg, right? Our mass times the acceleration of gravity. We're assuming we're on Earth here. So we replace the force with mg. We know that the force we use to pull up will be equal, or will point in the same direction as the displacement. We know the weight force does point in the opposite direction. So gravity actually does negative work on the object as it's moving to the table. But the force we use to lift the box is pointing in the same direction as the motion of the box as it goes upward. So the work we do on the box is equal to 39.24 joules. At the same time, gravity does negative 39.24 joules. And if we allowed the box to fall off the table, gravity would do 39.24 joules, because in that case, the gravity force would point in the same direction as the box moves as it falls off the table. And that's a quick overview of work.